Hello everyone, it's Forgive here, and I decided while I was building my calculator that I would be doing a video to sort of help people understand binary and exactly what it is, how it works, how to count in binary. Uh, it'll make the whole process going through the calculator a lot more simple, seeing as how most everything that happens in the calculator is binary, so we'll go ahead and start with the simple notion that our normal counting system, our 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, 11, 12, so on and so forth, our 1 through 9 system is known as decimal. And basically, deci just means 10. The whole point of our number system is that it is a base 10 number system, where every place is a multiple of 10, for example, or a power of 10, I should say. For example, when you have 1, your ones place is the equivalent to 10 to the 0 power. Pretty simple stuff. And then you have your tens place, which is the equivalent to 10 to the first. You have your hundreds place, which is the equivalent to 10 to the second, and so on and so forth. So each place represents 10 to a certain power, and it just goes on, and it starts at 0 and it just keeps going up. Similarly, with binary, binary is actually a base 2 number system. So where we would normally have our ones place, it's still actually a ones place because it's to the 0 power. But instead of being base 10, which is this right here, it's whatever number is being raised to a power, right? So instead of a base 10, binary is a base 2, bi meaning 2, obviously. So you have your ones place, which is 2 to the 0. I mean, the ones place is similar in pretty much every single number system. It's whatever that number is to the 0. So hexadecimal, which is a base 16, is the ones place is just 16 to the 0 power. In the ones place, you can only go up to the number of whatever base it is. So if it's base 10, for example, your ones place is going to consist of 1 through 9. Well, 0 through 9, actually. 0 through 9. That's going to be your ones place. And then in your 10, when you get to the tens, you have 0 through 9 again. If you think about it when you're counting, you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then once you get to 9, damn it, I can't highlight that, whatever. Once you get to 9, you go to your tens place, because that's where the next place starts. And then from there, you start at 10, which is the equivalent to your 0 in your ones place, and you go all the way up to 19. So it would be like this. And then you would go to 20 and so on and so forth until your tens, this one right here, not the 0, not that 0, because that's the ones. That's the 1 0. The 10 0. So you would continue this on until you got to 99. Because after 99, you're no longer in your tens place anymore. You're no longer in the tens. After 99, you're at 100. And that's your hundreds place. That's this one right here. 10 to the 10 squared, or 10 to the 2. And then from then on, you go all the way to 999, and then you go to the thousandths, and so on and so forth. It's until it works the same in every number system, it's just it looks different. In the tens, it looks like this. In binary, like I said, you can only use up to one, the number that the base is minus 1. So 10, you can only use 0 to 9. For 2, your next place is your 2's place, because it's 2 to the 1. So, and then after the 2's place is the 4's place, because that is 2 to the 2. Now, I'm going to show you how this works as well. Let's move this over here so it's a little bit easier to make a distinction between the two areas. Okay, so let me show you this. When you're doing binary, you can only, like I said, remember, it's 0 up to your base number minus 1, because when you get to the base number, you're moving up to another place. So, the 1's place in binary is, the only numbers that can appear there are 0 and 1. The 2's place in binary, the only numbers that can appear there are 0 and 1. It's 0 and 1 the whole way. Those are the only two numbers you're allowed to use. But the place of the number changes. So, for example, just because you have a 1 doesn't make it 4. Just because you write this doesn't make it this. In fact, it makes it this. And the way that that works is just like in decimal over here. When you go up a place, you actually move one spot to the left, right? Think about it. 1's place, right? But when you're in the 10's place, you're no longer doing this. Now you're doing this, right? Because you're in the 10th place. So it's this number that changes when you're changing the 10th place. It's the exact same thing in binary. So there's your 1's place, and then your 2's place, and I understand that the way that I'm saying it sounds awkward as hell, but sit through it with me, please. When you're in your 2's place, you actually move over to the left one. So, in our 1's place, say we put a 0. Well, the one to the left of this is going to be the 2's place. So, this number, 10, in binary, is actually, this equals our decimal 2. And the reason it does is because, if you remember, this is our 1's place, and our 1's place has a 0. So that's just 0. And this is our 2's place, and our 2's place has a 1, which means that this is 1 times 2 to the first power, which equals 2, right? 2 to the first power is 2, times 1 equals 2, which means that this is 2. And you basically just add the two numbers. So 0 plus 2 equals 2. Now, you might be thinking, oh, I just added these two numbers together. That's not the way that a decimal system works, is it? Actually, it is. When you think about the way that you count, you're actually adding the numbers together. Let me show you what I mean. 33, right? You have your 3 in your 1's place and your 3 in your 10's place. There's no adding there. You're just counting 33. But actually, you are adding. This is the equivalent to saying 3, and I'm actually going to put this in parentheses, 3 times 10 to the second, so 10 squared, plus 3 times 10 to the first, 10 to the 0. And this is not 10 to the second, this is 10 to the first. I apologize. Which this equals 33. How does it equal 33? Well, let's start on this side. 3, you have your 3, times 10 to the 0. 10 to the 0, if you look up here, 10 to the 0 equals 1. So this is 3 times 1. So this whole thing equals 3. Over here, we have 3 times 10 to the first. 10 to the first, if we look over here, 10 to the first is just 10. So 3 times 10, 30. So you have your 30 plus your 3, and that gives you 33. See? Even in counting, you are actually adding up the two numbers. But I guess it helps a little bit if you think of it more like you're adding the places together, not just the numbers. So if we go back to our binary over here, okay, now we can do, let's go even further. Let's do 3 places, right? This is going to be our 2 to the second, right? Our seconds place. This is our 0 place, our first place, our seconds place. Whereas this is our ones place, tens place, hundreds place. So let's do our seconds place. I want to write the number 7. 7 is the highest number that I can write in this place. Why? Because 7 is 1, 1, 1. How? And that is equal to 7. How does that equal 7? Let's cut it. Let's break it down, alright? So let's go into this number here, and let's break it down. This first one, this is our 2's place. So this is actually 1 times 4. Actually, I shouldn't write 4. I should write 1 times 2 to the second. And then this next one, and this is plus 1 times 2 to the first. Plus 1 times 2 to the 0. That is what it actually looks like. And I know that kind of looks complicated, and when it gets to the larger numbers, it's going to look even more complicated. But, like I said, this is the exact same what you're used to using over here. It's the exact same. The only difference being you have to count by powers of 2 instead of powers of 10. So, what does this come out to? Obviously 7, because I left it here. But let's start at the end over here. This 2 to the 0 is just 1. So, see? 2 to the 0 is 1. So 2 to the 0 times 1 is 1. And then we have plus 2 to the 1, which is 2. 2 to the 1 times 1 is 2. Plus 2 to the 2. 2 to the 2 is 4. Times 1 is 4 again. So we end up with 1 plus 2 plus 4. 1 plus 2 is 3, plus 4, 7. That's how you end up with that. Now, I know I told you that we can only use the numbers 0 to 1. 0 and 1, alright? So, oops, ouch, I just stuck my foot in my fan. That hurt. Anyway, moving on. You can only use the numbers 0 to 1. For example, this is not binary. This goes past our 0 to 1 limit. This is not binary. This isn't binary. It has to be, let me get this back there. It has to be either a 0 or a 1. For example, that's binary. That's a big-ass binary number, but it's still binary. So, now that I've shown you sort of how this works, our calculator uses a 4-bit number. 4-bit binary number, which basically just means it's 4 places, right? Right now, my decoder, or encoder, whichever one you want to call it, is just set to 0000 right now, because it's turned off. There's no input turned on right now. But it's a 4 place, right? So let's go ahead and I'll tell you the highest number that you can achieve with this 4 places, right? Obviously, it's going to be 1111, right? But that is not 1111. It is actually, can you guess? Let's go through it. Let's start at the end here, okay? Let's not make this any more difficult than it needs to be. So this is 1 times 2 to the 0. We knew that, right? This is 1 times 2 to the 1. This is 1 times 2 to the 2. And this is 1, that was an X. This is 1 times 2 to the 3. And all of these are added together. Alright, so what does this equal? Well, let's break it down for you. 1 times 2 to the 0, we all know this, 1. 1 times 2 to the 1, 2. 1 times 2 to the 2, 4. 1 times 2 to the 3. I don't have 2 to the 3 written here. So what is 2 to the 3? Remember, and this is for you kids who haven't actually learned powers yet. When you have a number raised to a power, all you're saying is take that number and multiply it by itself the amount of times that the power says to. Sounds complicated, it's not. For example, 2 to the 2 just equals 2 times 2. Simple, right? And this is supposed to be an equal sign. There you go. And then, moving on, 2 to the 3, or 2 cubed, is equal to 2 times 2 times 5. Just kidding, it's times 2. I accidentally put 5. So, what does that equal? Well, 2 times 2 is 4. 4 times 2 is 8. So, 2 cubed, or 2 to the 3, equals 8. So this, right here, is 8. Let's put that down. And just for the sake of balance over here, I'm going to write down the thousands place so that I have 4 places there. There you go. So this is 8 times 1. 8. Oh, and by the way, this 0, for those of you who don't understand powers, anything, it doesn't matter what number it is, anything at all, when it's to the 0 power. What about negative numbers? I think negative numbers count too. Any number to the 0 power, be it whatever number this is, to the 0 power, just equals 1. So, 2 to the 0, 10 to the 0, it's always 1. As you can see. Okay? Good. Now, what do we have here then? We have our 1 plus 2 plus 4 plus 8. 8 plus 4 is 12. Plus 2 is 16. So this is 17. So the highest number that our calculator can input is going to be 17. Am I going to make it input 17? Maybe. I'm kind of crazy that way. I might. Okay? I'll probably do like 17 minus 16. Or 17 minus 15. Or 17 minus 3. Something like that. as long as your answer is less than or equal to 17, because 17, remember, is the highest number that our calculator can make. If you want to be able to create a higher number than that, you're going to need more, not only inputs, but you're going to need more outputs. Because even though my calculator can input 17, it can't output anything higher than it if it's still a 4-bit calculator. Understand? I hope so. So this has been my explanation on binary and how it all works. Binary. Oh shit! I had a caps lock on, didn't I? Binary bitches. So I'll make this very strange document available for download. If you want to view it, I don't care. That's fine. It's a good little tutorial on binary. I hope it all helped you out, and I hope that using this, you'll more be able to understand what's going on with my calculator. So, alright, so this is Hiram. Have a nice day.